Right. I think I'm live. Can you all see my screen and can you all hear me nicely? Okay. Right. We start with this idea of the solar system. That's right. Right to say the solar system consists of what we call the solar system is a system of these things. Okay. One, the sun. Two, 8 planets. Okay. 3 dwarf planets. It's not part of the 8. Something else, dwarf planets. Of course, when we say a planet, we know that it will be orbiting the sun, something that goes around the sun. Okay, so we have these 8 planets, then we have some dwarf planets. We'll see what is the difference between those. 4 natural and artificial satellites. Satellite goes around the Earth. It goes around the planet. When it's a satellite, it goes around the planet. For Earth, the natural satellite, something which naturally goes around planet Earth, is the moon. The moon naturally goes around planet Earth, so it's a natural satellite for planet Earth. When you see the word planet, it goes around the sun. When you see the word satellite, it goes around a planet, not the sun. It'll be going around a planet. Then you say 5. Are we together? Say asteroids. Then 6, say comets. And you are done. Okay? If you know this, then you understand the solar system. Are we together, students? What we'll need to know is how it was formed. Then you'll be done. It's not too much work. Are you ready? For us to quickly go through the things that make the... So sometimes we can separate the natural satellites and artificial satellites. We can actually do it like this to make the things be 7. But I shouldn't do it since you've already written. So let's just write it as 6. Okay? Natural and artificial satellites. And then the asteroids and the comets. Have you seen it? Okay. So now let's go around this and let's start to learn the things one by one. Should we start? What should we start? The sun? Let's start with the sun. So what I want you to know is that things will be like this. Let me just give you a diagram of what the solar system will be like. You have the sun here. And of course, it's radiating its heat and light, whatever. And then the sun, we are going to have around it, you're going to have planets go around it. Planets will be going around the sun. So this is very, very important. You start with the sun, then you're going to start with planets. And when you do planets, here is how they work. The order. I'm going to give you a better way to remember it. Okay? My very excellent mother just us. Then you put Pluto. It's my very excellent mother just served us noodles. Then you put Pluto at the end. So this 1, 2, 3, 4, 5, 6, 7, 8. Pluto has disappeared from orbit, so that's why we don't normally put it. Here are the 8 planets that you must know. And this is the order from the sun. So you'll be having the sun. Then right after the sun, you're going to have Mercury. My is Mercury. Then Mercury is going around the sun, but it's closest to the sun. The path that it goes is closest. Then after Mercury, you're going to have Venus. After Venus, you have us, yay, Earth. Excellent. Then you go to Mother. Earth is like, okay, let me say Mercury, then you have a big Venus, then you have a slightly smaller Earth, then you have a slightly smaller Mars. And people really love Mars, eh? That's the one they've tried to go to see if there's life on Mars, It's this one after Earth. So it's further from, we'll talk about these distances, don't worry. It's further from the sun, but it's also going around the sun. Now, between Mars and Jupiter, this is the path for Mars. Then the next one, which is much, much bigger, the biggest is Jupiter, the very biggest. So this guy called Jupiter, actually, between Mars and Jupiter, this is where you are going to find things called asteroids. Are we together? So if I start to put them here, let's do it fast. It's in between Mars and Jupiter. Do you hear me, guys? It's in between Mars and Jupiter, okay? Yes. So this is where you're going to find. For comets, we'll talk about them, how they'll be near the sun. Don't worry. But particularly, they say the asteroid belt, where you find asteroids. The copper belt is like where you should follow to find copper. This is the asteroid belt where, in other words, if you keep following it, this is where you'll be finding your asteroids. It's between Mars and Jupiter. Okay? Please don't forget. In between planet number 4 and planet number 5. That's where you have your asteroids. These are small rocky objects. Okay? Small rocky objects. You find them moving around this area, which is between Mars and Jupiter. So if you try to go there, you're going to meet them. And the reason is, Mars is the very last planet which is rocky. And so after this Mars, between Mars and Jupiter, you're going to find some rocky objects there. But once you get to Jupiter, it is no longer a rocky planet. From Jupiter going to the last 3, it is going to be, okay, you do it, you go smaller, then you go, it's almost the same size. This is Saturn, just served as Uranus, noodles, Neptune. These are all gas planets. We'll explain. But now, these are gas planets. Can you see my screen? Can you see what I'm writing? If my screen freezes, somebody please call me, okay? If Misha, are you in the lesson? Simon, if my screen freezes, it's your duty to call me, okay? Immediately and say, sir, fix your screen. Right. Good. Here, remember, between 4 and 5, because the first 4 are rocky, the last 4 are gas planets. Between 4 and 5, the next planet must no longer be rocky after Mars. So what happens in between it? That's where you're going to find the rocks. Almost to say they threw their rocks there, So there are no more rocks. But anyway, these asteroids are found between 4 and 5. And we know that these first 4 are the ones that are rocky, guys. Come on now. So it's these first 4. These are the rocky planets. Then the last 4 are not rocky planets, but instead are gas planets. You should able to just do my very excellent mother. And for my very excellent mother, there are 2 M's. So you must know that the first one is the one which is Mercury. Then the 4th one is the one which is Mars. Then you'll be fine. This is a nice thing. Okay, now, the satellites you got to know, of course, are for planet Earth. So there'll be things that go around planet Earth. So there are things that they don't even... This is the path for planet Earth. Planet Earth has its own path like this. But whilst it's doing that, there is something which moves around it continuously, moving with it. One is the moon. The moon will be going around it every single day. And it's also moving because it has to keep going around Earth whilst Earth is moving. Then there is the artificial satellites like the International Space Station, where you had those astronauts that were stuck, and Elon Musk's company had to go rescue them after some months. They were stuck in space, but they didn't lose their life. They were just stuck there at the International Space Station. Okay, this is where people go to do some experiments. They leave planet Earth, they go there to try and do some experiments to see, can they find out something about planet Earth that we didn't know, about the atmosphere that we didn't know, trying to find a trace of life or whatever. That's an artificial satellite. It's going around Earth as well. So these ones are going around Earth. The natural satellite, which is the moon, and then the artificial satellite, the International Space Station. Okay, it's an example. So these are the satellites that you must know. They go around the Earth. And then these planets, they go around the sun. Then you've got asteroids. And then close to the sun, that is where you're going to have comets, which is just ice and dust. Okay, just ice and dust. Are we together? Okay. Don't forget that an asteroid is a rocky object. An asteroid. And it is found between planets 4 and 5. So have you seen the diagram of the solar system? Have you seen it? Okay. Now we just have to write about it. Okay, we just have to write about the things, and then we'll be fine. Write about what is this, what is that. I can give you a table maybe before we write more as notes. Let me just give you a table which summarizes it. Say objects in the solar system. Let's do them. The objects that are in the solar system. I'm going to make a table for you. In this table, it's going to have object. Then after object, it is going to definition of that thing. Okay. So definition, in other words, what it is. Let me say what it is. Then let me say here, what you must know about it. Let me just say what you must know. Some important things you must know about this object. Really? Yes. Should we write them down? Yes. Okay. Object number 1 in this solar system, the main thing is the sun. So, the sun. This is the first object. Object number 1. Say the sun. What is the sun? What is it? It is a star. The sun is a star. Okay? It is the center. You're going to see when you talk about nebula, the formation of this solar system, how it was formed. Okay, we're going to talk about it, the nebula just now. And you see that the sun is what formed at the center. So it is the center of the solar system. No, it's not the center. That's not true, sir. In your diagram, it was on the very leftmost part. No, it's because it was a diagram of one view. The reality of it is, you see, here we put the sun like this. Let me put it in yellow. Here we put the sun like this. But come on now. Can't you see that these things are going around it? So they will not actually be in a nice line like this. Mercury could be on the other side here, on the other side of the sun. Right? In reality, it could be like this. In reality, it could be like, here is the sun, you know, the most massive, of course, object. And Mercury is actually this side. We know that its path is the one which is closest to the sun. Then after that is Venus. We know that. Okay. So this could be Mercury. And Venus will be in its path. So let me put Mercury's path like dots. They are not all on the same side. That's basically what I'm trying to show you. That these planets, it's not like they'll be on the same side like we just showed you. No, we were just showing you that the other one has its path which is further than the other one and stuff like that. Are we together? Can you understand that? Huh, guys? Yes. When you actually put it, you'd be having, you know, let me put it here. It's quite big, Venus. And it'll be like this. It could be like here. And then you can have your planet, Earth, which is slightly smaller, somewhere here, which has its own. And now you can actually now see that the sun is at the center. Okay, this will be Earth. This is Venus. This is Mercury. So the sun is at the center of the solar system. You see now, all the planets are going around it and round it, and it is the central thing. Okay? Let's quickly write. You heard me. The sun is the center. So, center of the solar system, and it is the most massive object. The largest object. Most massive object of the solar system is the sun. Then we can put the 8 planets. But what you should just know is that when we say we have a planet, so 2 is the 8 planets. The 8 planets. What are they? What is a planet? Okay? It is a body, let's just say a large body that orbits the sun. That will be qualified. That will be something that we are going to say is a planet. It is a large body that orbits the sun. Now, the difference between a planet and a dwarf planet is that a planet has enough gravity. To clear nearby objects. What is gravity? It is when it pulls something to itself. Do you understand? Hello? If you have gravity, it means you pull something to yourself. So if there is a nearby object that is moving around planet Earth, it is going to fall on the Earth. Do you hear me? Because the gravity of the Earth, here's the Earth, it pulls something. Airplanes, they fly above planet Earth like this. What happens if their engine fails? They have a crash. Where do they crash? On Earth, because they are pulled down by the force of gravity. So that gravity in Earth will pull down the airplane, and it will come and hit the strong surface of the Earth, and that will be a plane crash. Are we together? Guys? Everyone? What we will be calling a dwarf planet, it doesn't have that ability. It cannot clear nearby objects with gravity. It can't. Its gravity is not strong enough. So this is a smaller planet-like body. Okay? What you must know is it cannot clear nearby objects with gravity. This is what you must know about a dwarf planet. Are we together, guys? Then now we say moon. Now we say moon. Moon is natural satellite. That is the moon. It's a natural satellite. What is a natural satellite? We know that satellite is just something which orbits a planet. So a moon, it orbits a planet. Many planets have moons. When we say we have a moon, it's just a natural satellite. Are we together? Okay? And what is a satellite? Anything that goes around a planet. What is a planet? Anything that goes around the sun. Okay? Are we together, students? Let's do the fifth thing now. Let's do the fifth thing. We have more. 5. Artificial satellite. Like the International Space Station. What does it do? It is a man-made satellite object. Okay. Man-made. What does it do? Okay, let me say it also orbits a planet, which you know it'll be like Earth, e.g., say International Space Station. Are we together? Guys? Let's see the sixth thing. Asteroid. Asteroid. This is a small rocky object. It's not that small, but when it compared to planets, it is small. Okay? Say, are you not afraid that asteroids can fall on us? Where are they found? They are found out there after Mars. Thank you. So you've answered yourself. So right here, mostly found between, not between Earth and Mars, but between Mars and Jupiter. Number 5. Then, the last one is a comet. The last one is a comet. It is ice and dust. Okay? Objects made of ice and dust. Okay? What should you know about this type of an object? Is it has a highly elliptical. By elliptical, it means, you know, these guys, we had the sun here, and we saw that the planets go around the sun nicely. They evolve like this. If it is an asteroid or a comet, it has an elliptical orbit, not something circular like this. It will go close, then far, then close, like this. This is elliptical. It means it's not a circle. It revolves like this. This is something, this is elliptical, which is not circle. It's not a circle. It's not a nice circle. So it is a highly elliptical orbit. and should say it forms the tail near the sun. Are we together? Are we together, students? Now, if I can just write key statements that I said here, was that dwarf planets, remember that, NB. Dwarf planets are different from these planets of ours. Okay? Right? Are different from planets. Okay? Because their gravity, this is the difference. Their gravity is not strong enough to pull in. Okay? The other words of that is to clear. To pull in or to clear nearby objects. Like I said, if anything happens to an aeroplane, aeroplanes do not fly inside the earth. Hi, Hamid, this is physics. Yes. In a few more minutes, in like 20 minutes, okay? 1:45. Okay. This is the earth. Nobody stays inside the earth. We've studied geo, right? If you go inside the earth here, there is nothing. There are layers. There is no human being here. People stay out. People stay on the surface here. This is where you are right now. You are on the surface of planet Earth in all your respective countries. This is where you are. This is where a human being is. Yay! This is some are in USA, some are in England, some are in Norway, some are in Egypt, some are in Honduras, some are in Cyprus, some are in the United Kingdom, some are in, India, Pakistan, all those different countries, everybody, all like this, all having fun. And before now, what you must know is that the earth is pulling all of us. That is why we don't fly away. The earth is pulling us towards the center. But because the ground is so hard, we are blocked by this ground here. So we will end up staying on the ground. If you try to jump up, it's going to pull you back and you're going to hit the ground because it is trying to pull you inside. It wants you to stay close to it. It pulls you in the earth. That is why everybody, you go in a tree and the tree breaks, you are going to fall down. You are not going to fly. There's no Superman here. The gravity is going to pull you down. Right. Airplanes fly like this. They take off, then they fly around like this, then they land. So airplanes are in the sky, which means they are here. This is where an airplane is. Okay? Because they are in the sky. They are not on the planet. This is an airplane and it's flying. Now, what happens if it has a plane crash like this? It will be pulled and it will have, if it has an engine failure and all its engines are dead, it will have a crash. So it will go and hit because the earth will pull it towards the center. Okay? Earth will pull it towards the center, but we know that the ground is so hard. So when it gets to the ground, it will crash and change into a flame. Okay, so we can all see that the earth is impressive. It pulls everything back to itself. So everything falls down. Yes. Oh. But when we say we have a dwarf planet, it can't do this. Yes. dwarf planets will not pull you so that you fall on them. No. You only fall onto planets themselves. Are we together? Now, asteroids. We said asteroids are small rocky objects mostly found in the asteroid belt. In the asteroid belt, which is obviously between Jupiter and Mars. You say between, start with Mars because it's the first one. Between Mars and Jupiter. Right. And then comets, the last thing, okay? Comets, we said, are made of dust and ice. Comets are made, instead of rocky objects, these ones are made of dust and ice. Now what happens is, because their orbit is highly elliptical, sometimes they come very close to the sun. Yes. Okay. Their orbit is not nicely circular. It is an irregular circle type thing. So they have a highly elliptical orbit, and therefore sometimes come close to the sun. Now, what I want you to write is that when comets come close to the sun, ice melts and forms a tail. So you see them having something like a tail. Are we together? These things made of dust and ice. Have you seen? Students, are you seeing this? LGK. Mm-hmm. Yes. Highly elliptical, we said it's like this. We said it's like this. Here you have the big sun. And then Mercury. Then you have in blue. Okay, let's keep it nice. May not make it ugly. I want to make it as nice. Here is your Mercury. Nice circle. Goes nicely around. Then here you have your big Venus. Okay, I don't have to put it here. I can put it here. Your big Venus. All these guys are going nicely around the sun. Now, and you have Earth as well. When you have a comet, this is how it goes around the sun. Comes like this. It does this. You know, something like this. This is an ellipse. Okay, you can look for the shape of an ellipse, you see it. So it's just, then this side, it actually now goes far like this. Can you see? Are you seeing? And now this will be, obviously, this is your comet. When it's close to the sun, it melts. The ice on it melts. Then you're going to see on your comet tails. Let's say this is your comet. You're going to see tails on the comet. This is what we meant. So it'll be nice. And you see, it looks nice, like it looks like something that has tails. This is your comets. Look at how it goes around the sun. Sometimes it's close, sometimes it's far. That is it. It's not nicely thing. It's spherical. Okay? You've seen it? So if you say elliptical, it means it's not a circle. Okay? Not circular orbit. Anyone with a question here? Guys? Excuse me. Anyone with a circle? Anyone with a question? All right. Now, let's do a bit of interesting stuff. We're almost done. If we are going to put, everybody has seen that. Let me just say this, since you all have seen. Everybody has seen that when you talk about planets, they go around the sun. When you talk about comets, they pass around the sun. When you talk about the asteroids, they also go around the sun because they'll be in their thing. So they all go around the sun, except the natural and artificial satellites. Those go around planets. If the natural satellite is a moon, it goes around a planet because many planets have moons. But if it's now the artificial satellite, it is man-made, and all artificial satellites are made to go around the Earth. Are we together? Okay? Guys? So, planets, the 8 of them. Okay? If we can say the 8 planets. Any planets. I don't care. 8 planets, dwarf planets, asteroids, comets. They orbit the sun. They go around the sun. Natural satellites, e.g., moon. Don't think the only moon is the one we see on Earth. That's our moon, but there are other moons. All planets have moons. So they orbit around planets. Okay. Natural satellites orbit planets. Anything called a satellite, because it orbits a planet. Then artificial satellite, e.g., what? E.g., I.S. I didn't hear that. Speak again. Besides the moon, you only have to know the moon. You only have to know the different types, that there are different types of moons. Okay? You just have to know that there are different types of moons. That's important. That's just the type of natural satellite you're supposed to know, okay? Now, if you go to artificial satellite, e.g., the ISS, they orbit Earth. They orbit Earth. Artificial satellites orbit Earth because they are man-made. Thanks to Elon Musk, we've got more. Huh? Starlink, yay! It's using these things, satellites. Okay, not many small ones, all over, that will be orbiting the planet Earth and giving some serious Wi-Fi there. You understand? Guys, you don't have to wait for one satellite far away, which will be costing you because you'll be having slow internet and you are frustrated. You are not happy. You can't work. You know that you can do better, but the Wi-Fi is slowing you down. That's so frustrating. So you need great Wi-Fi like Starlink. Yeah. Right. Order of 8 planets. I hope somebody will be an entrepreneur and also give Wi-Fi's or whatever in the solar system. What did we say? This one is easy. We are just recapping. What is it? My very excellent mother just served us noodles. Have you forgotten, guys? And I say, don't say Mars on the first one. We know that there are 2 M's, Mercury and Mars. The first one has to be Mercury. It's not Mars. Mars is after Earth. It's far away. These other ones are obvious. This is Earth. This is the Mars. This is Jupiter. This is Saturn. This is Uranus. When I went to school, we had athletics, and athletics, we had the names of the clubs were after these things that are in space physics. We had a club called Saturn. We had a club called Apollo. We had a club called Mercury. We had a club called Gemini. How cool was that? That was nice, right? So Saturn. Or it's a house. Then you have Venus, then you have Earth, and you have all these. This is way too easy. Now let's go to the next thing. Okay. Right. In the exam, there's a thing I wanted to show you. I'll show you the questions when I'm done with this. I want you to just write these notes. There's a question I really almost showed you. I wanted to show you. Maybe I should have. Where it gave you a table. It's a 2025 question, guys. Okay? Physics, past paper. I love to look at them. I love to analyze them every time. It gave you a table, and it gave you distances, and then it asked you to predict the next one and stuff like that. So there are some trends that I need you to know. Okay? Can you write for me this? Because I don't want you to try to memorize unnecessary numbers. Okay? So write for me to do this. Write for me to say trends in orbit distances. Okay, we want to see what happens the further you go away from the planet, from the sun. I mean, the further you go away from the sun. When you look at Mercury, which is very close, it orbits very close to the sun, and Venus and Earth, when you're going down like this, what pattern do you see? So, okay, let's put some main trends. Okay? Hello? As distance from the sun increases, in other words, as we go down like this, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, as we are going down, what do we expect to see? The distance from the sun is increasing. What do we expect to see? Let's look at it. 1, orbital period. Period is the time it takes, right, to go around the whole thing. It increases. So definitely, we know that Neptune takes longer than Saturn to go around the sun. What about the speed? We know that they are traveling a greater distance. They take longer. But who is the fastest moving? Does Mercury move faster than Venus? Does Venus move faster than Earth? Or is Earth faster than Venus? Let's do it. Orbital speed decreases. The Earth is slower than Mercury. It's slower than Venus. Do you hear me? Hello? Do you hear me? Okay. What about the temperature of the surface, where let's say you would stay there? What about the temperature? The mean surface temperature. What about this temperature of this planet? The average temperature of this planet. What happens here? I want you to say it decreases. So you're going to see it, okay, decreases. Except Venus. Except Mercury to Venus. This is where there is an increase. But generally there is a serious decrease there. The further you go from the sun, the cooler it gets. But Venus is a problem. He is actually hotter than Mercury. Oh, really? Yes. So is that why we've never heard of anything going to Venus? We only go to Mars? Yes. We only send rovers, not people though. There is no life at Mars. We only send, or there is no sign of life at Mars. We only send some robots there to Mars. Then number 4, you can put many trends. Many trends. Are we together? But here I want you to have these as the main ones. Okay? Guys, you can put density as in how heavy is the planet. as you move. The density decreases. Who is the anomaly? Is the Earth, except for Earth. Really? Yes. So the Earth is heavier. Yes. Why? Because there are people and animals that make it heavier. Otherwise, okay, so Earth is heaviest, by the way. It has the highest density. Earth has highest density. It obviously means it's the heaviest when you look at its size. For its size, Earth is the heaviest. Okay? But there are some obvious things. We said the period increases. In other words, when you are further, it takes you longer to go around. And you'll be also moving slower. You'll be colder. You'll be lighter. The further you get, the lighter it gets. Further the planet, the lighter it is. Okay? You know that. You know that first 4 planets are rocky planets, which means they are obviously heavier. They obviously have higher density. Do you remember that the first 4 planets are rocky planets? Students, do you remember that? And they go to some gas planets, but gas planets are huge. Gas planets, you see that they are very big. Gas planets are big, but they cannot be heavier for their size. They are lighter. Okay? So diameter, I want you to say, put here to say, so everybody knows. So once you say the word Jupiter and Uranus and these last ones, that's the last one I'm putting. Say diameter. Say gas planets are huge, are giants. Okay? But I want you to say, but diameter decreases for them from Jupiter to Neptune. But they are still larger than rocky planets. Write that. The rocky planets are smaller. Are we together? Okay? Guys, have you written this? Okay. I'm going to end here. Well done. Well done. And which ones are the rocky planets? Are they the outer ones or the inner ones? The inner ones, the 4 inner ones, the ones that are closer to the sun, the ones that are hotter. They are rocky, but they are small. So they are rocky, very rocky. It means you find heavy materials on them. You find metals on them. You find rocks for them. You find the planets that are made from rocks. But when you go to outer planets, you find that they will be very large, but they will be, of course, they will also be cool, but they will be gaseous. You find light gases there. You find helium there. You find methane there. You find hydrogen there. Gases, they are gaseous planets, or gas planets, giants. But the inner ones are small, they are rocky, they are hot because they're close to the sun. So they're close to the sun. So they are hotter, they are rocky, they are smaller, but they are denser, very heavy. Right? Well done. What you're just left with, since you now know this, is you should now know what we call the accretion disk and how it was formed. It's a simple thing. You start at nebula, then you see what happens so that we end up having the sun and the planets. What happens? Then after we are done with this, we will say, well done. This will be the last thing. You will say, well done. You now know the solar system, and we are going to lock in on understanding. We're going to lock in on understanding. What is it? The Big Bang Theory, whatever. I'll just mention in passing a few things that you don't need to do, like the speed of light, gravitational field strength, blah 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 blah. We'll just give you a few things, but don't worry about it. This is going to be easy. Okay, I won't give you. You won't have too much to do because calculations, we know the formulas. I'll remind you, and we'll do calculation questions. So, theory, we are almost done. We can actually say we are done. We just have to do how the planets were formed, and then we are done. Then we can go to the last bit of chapter 2. Remember, what we are doing is the first part. We have the second part of chapter 6, which is the stars and the universe. It's much shorter though. Okay, it's much shorter. We will learn about the Big Bang Theory, then we'll learn about galactic redshift, then we'll learn about the life cycle of a star, then you are done. Right, that'll be the work for this week, of course. So we've got our work cut out. We know exactly what is expected of us. We have no surprises. Any questions here so far? Is there anyone with a question? No question. Okay, I'll give you a small assignment. Please make sure you submit the notes at the end of the lesson, and I'll give you the link. I'll open up the link by the end of the lesson. Submit it and get yourself